Assalamualaikum warahmatullahi wabarakatuh and good day student. Okay, now we are entering chapter 5, which is the last chapter to be covered in EQT 101. Right, so in chapter 5 we will learn on partial derivatives. First, I would like to introduce to you the notation used to denote partial derivative. Okay, let us assume that we have function f where this function is depending on two variables which are x and y. Okay, so you have a function f which is depending on x and y. So in that function, there will be a x and y variable in it. Okay, right. So the concept of partial derivative, okay, is we will partially differentiate our function here with respect to a chosen variable. Okay, and thus you will treat the other variable as a constant. Okay, for example, if you want to differentiate this function with respect to x, okay, we will write delta f over delta x. So delta here, okay, del here is referring to partial derivative. Okay, so it means here that we just differentiate the function here, okay, our function f here, with respect to variable x only, and thus the variable y in the function we will treat as a constant. Okay, right. So next, if we want to find the derivative with respect to y, we will write del f del y. It means we will differentiate function f partially with respect to y, and thus we will treat variable x as a constant. Okay, so this is called first order partial derivative. It is called first order because we differentiate just one time with respect to the chosen variable. Okay, so since we only have two variables here, which is x and y, thus we will have only two first order partial derivative. The first one with respect to x, the second one with respect to y. If we have more, for example, if we have x, y, z, and w, we will have two additional variable, which is two additional first order derivative, which is del f del z, and the fourth is del f del w. This is if we have f with function x, y, z, and w. Okay, so it is not just restrict to only two variables, it can have more. All right, but in EQT 101 you will just test it until two variables. Okay, function with two variables. Okay, so don't worry about the rest. Okay, right. We also can have second order partial derivative. Okay, it is called second order because once we differentiate our first order one more time, it will become second order. Okay, so if we differentiate f two times, okay, you will get second order partial derivative. Alright, so since you have two variables here, you can have 4 second order partial derivative. Okay, so you will have 4. 1, 2, 3, 4. Okay, so the first second order partial derivative, when you differentiate f with respect to x 2 times. Okay, so the first order, which is del f del x, and then you continue differentiate this one more time, you will get del squared f over del x squared. Okay, so you are differentiating your function f with respect to the same variables, okay, which is x. You will get del squared f over del x squared. And you can also do so, okay, do the same thing to your y. When you differentiate the first order one more time with respect with the same variable y, you will get the second order for the same variable. Okay, and you can also differentiate, okay, with respect to different variable. Okay, first you can differentiate with respect to x first, which is this. Okay, so you will get the first order where you differentiate with respect to x, right? When you do second time, you can differentiate this function with respect to different variables. So you will get del f del x. This will become your first derivative. And then you continue to differentiate this time once again, but with different variable. So you will get del squared f del x del y. Okay, so this is for the first time, and for the second time you perform with respect to different variable. Okay, right? So you will get the third one. The fourth one, okay, is when you differentiate your first order del f with respect to y, and then you continue to differentiate once again, but with different variables. Okay, since the first one you start with y, the second one you start with different variable, which is x. So you will get del x. Okay, so look at these two partial derivative, second order derivative. Okay, look at carefully. When you write dx first, it means the first derivative you do for x first. You differentiate with respect to x first, and followed by the next derivative followed by second variable, which is y. Okay, so second time you differentiate with respect to y. The fourth one, you do for y first. You differentiate with respect to y first. And the second time, you differentiate with respect to x. Alright? So remember, partial derivative, use symbol del. Okay, this symbol. Okay, this means partial. Okay, partial means you differentiate your function partially just with the chosen variable, and you treat the other variable as a constant. Alright, so if you still remember implicit differentiation, okay, what is the difference of implicit and partial? I will answer this in the next slide. Okay, before I explain on the difference of partial derivative and implicit differentiation, first I would like to teach you on how to perform partial derivative. Okay, so that at the end of these examples, you can differentiate by yourself the difference between these two differentiation. Okay, so look at example 1 here. Write down all partial derivatives of the following function. Okay, so when it's mentioned here all partial derivative, it means that you need to find the first order of partial derivative and the second order of partial derivative. Alright. Okay, so you have function f which is depending on variable x and variable y. Okay, you can obviously see that in the function here where you have x and y, x and y, y and x. So this function is depending on variable x and variable y in the function. Okay, right. So we need to find the first order partial derivative. The first order, since there are two variables here, means we will have two first order partial derivative. Okay, so the first one is del f del x, and the second one is del f del y. Okay, because we just have two variables. Alright, so we differentiate with respect to the first variable, followed by differentiating the function with the second variable. Okay, now we will differentiate function f here with respect to x, which is our first variable. Alright, so since we choose to differentiate our function here partially with respect to x only, thus we will treat y as a constant. Okay, so where is variable x? Variable x we have here x, and we have ln x. Okay, so our eyes will just concentrate on x. This is the term that we will differentiate. Okay, and what will happen to our y here? This will be constant. Okay, when I say constant, means they will stay as they are in the function. Okay, so your eyes will just look at term x, 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 x. Okay, and just differentiate the term with x. Okay, so now what will happen to your x function here is, okay, differentiating x cubed. What will you get? You will get 3x squared. And you treat y as a constant, so it will stay. Okay, so to the second term. Differentiating x, you will get 1. Alright, so sin y will stay. So you will get sin y. Okay, and then the third term, you have ln x. Differentiate ln x, you will get 1 over x. And y, since you treat y as a constant, so it will stay. Okay, so the answer is del f del x. Okay, partially differentiate your function with respect to x is 3x squared y cubed plus sin y plus y over x. Okay, easy? Alright. Okay, now we will differentiate function f here with respect to y. And thus, we will treat x as a constant. Okay, so where is variable y? We have y here, and y, oops, sorry, and y here. Okay, so x here will be constant, means it will stay in the function. Okay, right? So differentiate y cube, you will get 3y square and x will stay. Okay, go to the second term here. Differentiate sign, you will get cos y. So differentiate y, you get 1. So no problem. X will stay. Okay, because it's constant. Plus with differentiate y, you will get 1. Okay, ln x will stay. So ln x. Alright, so this here, del f, partially differentiate your function f with respect to y is 3y square x cubed plus x cos y plus ln x. Okay, so as easy as that. So we are done with the first order partial derivative. Now we will proceed to second order partial derivative. Remember, since we have two variables, okay, so for second order we will have 4. The first one is del squared f with respect to the same variable x. The second time del f with the same variable y, and the third and the fourth is called mixed partial, because the first one we differentiate with respect to the first variable, followed by the second time we differentiate with respect to the second variable. Okay, and alternately the fourth one will do for y first, followed by with respect to x. Okay, so these are 4 second order partial derivatives. Alright, so these two are differentiating with respect to the same variables. Okay, and these two is called mixed partial. Okay, mixed partial, where we alternately differentiate them by using the different variables, okay, as their first order partial, right? So we know that second order is differentiating the first order second time. Okay, so what it means by del square f over del x square, it is simply means you are differentiating your f, okay, partially to your first order. Okay, so this is your first order. Differentiate this first order partial derivative one more time by using the same variable, which is also x. Okay, so what you do here, it will become this. Okay, differentiating the first order for the second time is equivalent to this notation. Okay, so now same thing, you will just concentrate on x only for the second time. Just look at x. Okay, where is x? Here. Do you have x here? No, no x here. Do you have x here? Yes, it is here. So you only have two terms. with x. Alright, so concentrate on the x, differentiate the first term here. You will get 2 times 3, that is 6x. Okay, and y will remain. Okay, plus with, you have no x in here, so only y. So you treat y as a constant. When you differentiate a constant, what will you get? You will get 0. Okay, so this one, differentiating x 1 over x. Okay, you can rewrite this to yx negative 1. So what we will get is negative yx minus 2. Okay, so 6xy cubed minus y over x squared. That is the answer. Right, so this is your del squared f over del x squared. Okay, now you will differentiate the second derivative of y. Okay, right, so differentiate your first order of del f del y. You will get del squared f del y squared. Okay, so now you will just concentrate on y because you are interested on variable y only. Okay, and you will treat your x as a constant. Okay, so when it is a constant, just it will stay here. You just differentiate this. Alright, right, this one is, it won't stay because you have no x. Okay, so you just only have a constant by itself. Alright, so you just have a single constant here. For example, 2. 2 is a constant, right? When you differentiate 2, what will you get? You will get 0. But it is different if you have 2x. Okay, 2x. 2 is a constant. X is the one that you are interested to differentiate. So you differentiate x here, you will get 1. Right? So 1 times 2 is 2. Okay, so you see the difference here? Okay, this is what happening here. Okay, right. So differentiate your y here. You will get 2y. Right? And 3x cubed will stay. Plus with differentiate cos y, you will get sin y. And x will stay. Okay, differentiating ln x. Okay, you have no y in here. So ln x is a constant. Differentiate a constant, you get 0. Alright, so the answer is 3 times 2 is 6x cubed y minus x sin y plus 0. Okay, so this is the second order partial derivative for the two same variables. Okay, x squared, y squared. So we have two remaining second order partial derivative, which are del squared f, del x, del y, and del squared del f, del y, del x. Okay, so this one means you differentiate with respect to x first, okay, followed by differentiating your f with respect to y. Okay, so make sure the first derivative is with respect to x, and when you perform the second time, forget about x, concentrate on y. Same goes to here. Okay, this means you differentiate del f with respect to y first, followed by del f del x. So make sure the first order you differentiate with respect to y. So you concentrate on the variable y. When you perform the second time of differentiation, forget about y but concentrate on the x. Okay, so let us go to the differentiation. Okay, so I will delete this to give some space. Okay, so this is the first order that we got from our first order differentiation just now. Alright, so when we want to find the del squared f del x del y, this is our first mixed partial. Alright, it means our first, okay, we do for x, which we already got it from the first order. Okay, so this one, what we have here, we got this from our first time. We differentiate the function for the first time. This is what we got when we differentiate our function with respect to x. Okay, so this is from the previous one, the earlier one. Okay, then we differentiate the second time now with respect to y. Okay, so if for the first one we concentrate on variable x, now for the second time, okay, from this function, concentrate on y. Okay, concentrate on y, which is this, and this. So we will differentiate the y. You will get 3x square, 3y square plus cos y plus 1 over x. So we will get 9x squared y squared plus cos y plus 1 over x. Okay, and when this is the answer for del squared f, del x, del y. Now let us look at the second order when the second time you concentrate on x. Alright, so the first one, this is the first order. Okay, when you want to find del squared f, del y, del x, means you will differentiate your first order here with respect to x. Okay, so the first time you differentiate, you are interested to variable y. Okay, variable y. But the second time you differentiate, you are interested on variables x. Okay, so you have x, x, x. Okay, so you will get 9x square y square plus cos y plus ln x, you will get 1 over x. Okay, so do you notice something here from del squared f del x del y and del squared f del y del x? Look at their differentiation. Yes, the answer are similar, right? So we can conclude here that our mixed partial, whether you differentiate with respect to x first followed by y, or you differentiate your function with y first followed by x, you will get similar answer. Okay, so this is the property of mixed partial derivative, where the mixed partial derivative del squared del f over del x del y is equal to del squared f del y del x. Okay, so no matter which variable comes first, you will get similar answer. Okay. Okay, so from the example 1, we observe that these two mixed derivatives are equal, and these properties hold for all function. Okay, for all function, when you perform mixed derivative, you should get similar answer. So it will satisfy all function. Okay, right? So the mixed partial derivative must be equal whenever f is continuous. Alright. Okay, now I will explain on the difference between partial derivative, and implicit differentiation. Implicit differentiation and partial derivative. Okay, so the difference between these two. Okay, before we go to the difference, okay, let us look at the similarity between partial and implicit. Okay, so both of these differentiation we perform when we deal with function that contain two variables and more. Okay, right? So we have two variables in a function. For example, you have x cubed y squared plus x y, for example. Okay, so obviously here in this function it depends on variable x y. So you have two variables, right? So when we perform implicit differentiation, we do not treat the other variable as a constant, right? We will differentiate the function with respect to x only, while the variable y we will perform implicit differentiation. Am I right or no? Right? So if we differentiate this function, okay, and let's say this function is equal to 0, okay, what happened is we differentiate x as usual. So it will become 3x squared. Right? This you need to do product rule to this, right? Okay, so you have u equal to x, v is equal to y squared. So du dx is 3x squared, while for dv dx is 2y dy dx, right? So what you will get here is x 3x squared we multiply to y squared plus with x cubed 2y dy dx. Okay, and same goes to this. You will also need to perform the derivative, sorry, not derivative, products rule. Okay, where u is x, u prime is 1, v is y, and v prime is dy dx. So what we will get is x dy dx plus y. This is equal to 0, and you need to put together all the dy. So you have 2x3y plus x dy dx equivalent to minus y minus 3x squared y squared, and thus dy dx is equivalent to minus y minus 3x squared y squared over 2x cubed y plus x. Okay, so you will get the differentiation of your function y here with respect to x only. Okay. Okay, obvious? Obvious, right? Okay, you don't treat y as a constant at all. Okay, you will differentiate y as you differentiate your x. But for y, it will come with term dy dx. Okay, this is implicit. But for partial derivative, when you have this kind of function, you will treat the other variables which is you are not interested to differentiate with respect to it as a constant. Okay, so what I mean here, will you differentiate your f here with respect to x, means you are just interested on variable x, so the y will be constant. So what you will get is 3x square y square plus y. Okay, same goes if you are interested to variable y. So you will treat your x as constant. Thus, you will get 2yx cubed plus with x. Okay, and you can do so for mix and so on. Alright, so it is obvious. They will have similar function. Okay, where we perform partial derivative and implicit differentiation to a function which has more than one variables. That's it. And then the way we differentiate them will be different. Okay, in implicit, we do not treat any of the variables as a constant. Okay, we will differentiate both. Okay, it's just that when we deal with y, variable y, we have extra term of dy dx. Okay, and for partial, we just, okay, since it is partial, means we only interested to certain variables. Okay, and we will treat the other variable as a constant. Okay, so hopefully it is obvious for you on these two differentiation. Okay, let us look at second example here. Write down all partial derivative of following function. So we will find all the partial derivative. So let us perform for the first variable first. Okay, so find the first order of partial derivative. Okay, so del f del x. Okay, so we are interested on the variable x, so treat y as a constant. So just look at x, x. Okay, so you have three terms. Okay, so we differentiate, it become 10x. Exponent will remain, and this one will become, differentiate x, you get 1, so you will just have 3y, and that one, the third term will become 6x squared. Okay, then the second first order partial derivative is with respect to y, so we will treat x as constant and differentiate on y. Okay, so y we have here and here, so we do not have x here, so this will become 0 later when we differentiate, right? So 5x squared will remain. Differentiating exponent for y will get exponent for y. Differentiate for y, you will get 4. Okay, then plus with differentiate y, you get 1. So you just left with 3x. Right? So this will become 20x squared exponent 4y plus 3x. Done. Okay, next we proceed to the second order partial derivative. Okay, so for second order partial derivative, just now we do for x, the first one we do this, right? Del f del x, where we get we differentiate the x only. Okay, so we have 10x exponent 4y plus 3y minus with 6x square. Okay, this is the first. Okay, then we will do the second order, where we will differentiate this one more time with respect to the same variable. So we will get second order of del f del x square. So concentrate on x one more time. Concentrate on x only. X. So you don't have x here. So this will be constant later. And you have x here. Okay. So differentiate 10x. You will get just 10 exponent 4y. This term will become 0. This will become minus 12x. Okay, so this is the second order of the same variable x. Okay, we also can do mix. Okay, where for mix, we will differentiate the first order here, which is del f with respect to x. Okay, for the second time, we will look at y. Okay, so what happened here is, from the first order here, where the first one with x, so it's fine with x. The second time, we will refer to this function. Now, just look at y, because we are now interested on variable y. So, which y we have? We have here, we have here, and we do not have y in here. Okay, so start differentiating with respect to y. So the first you do for x. So you get this function, the whole function here, 3 terms. Now you just concentrate on y. You're no longer interested on x, but you are interested on y. So you just differentiate term with y and treat the x as a constant. X will be constant. So x will be constant. Okay. So differentiate exponent for y, you will get 10x exponent for y. Differentiate for y, you will get 4. Okay, differentiate 3y, you will just get 3. And this is a constant only, because you do not have variable y here, just variable x. You don't want x, you treat as a constant. So it becomes 0 for that. Okay, this will become 0. So this is the answer. 40 x exponent 4y plus 3. So this is your mixed partial. Alright. Okay. Right. So next you will do for y. For y, okay, from first order of y, what you get is you concentrate on variable y. I delete this. Okay, concentrate on y. So you have here, here, you don't have y here, right? So what you got is 5x square exponent 4y times 4 plus with 3x only. Okay, so this is the first order that we got just now from the previous slide, right? I just do it one more time so that you can see directly what will happen when you perform the second derivative. So you have 20x square exponent 4y plus 3x. Okay, So now you will differentiate this first order once again with the same variables. Okay, so that you will get del squared f del y squared, which is once again you still interested on variable y. So you don't have y here, so that will become a constant. So for del squared f over del y squared, you will get 20x squared because this is constant. So exponent for y, differentiate for y, you get 4. So you will get 80x squared exponent for y. Okay, now differentiate one more time del y, but now you are interested on variable x, so you will get del squared f del y del x. Okay, so the first time you differentiate, you are interested on variable y, so that's why from here you look at y. Okay, you will get this when you differentiate with respect to y. For the second time, when you want to differentiate this function, okay, so this, you said differentiate second time, now you are interested on x, okay, no longer interested on y, but now interested on x. So that's why from here, just look at x term. So you have here, you have here, so your y will become a constant. Okay, now we need to refer to this lah, right? Which I delete this. So delete this, that, and that. Okay, interested on x. Where is our x? We have here, we have here. Okay, so differentiate with respect to x, you will get 40x exponent 4y, and differentiate 3x, you will get 3. Okay, look at this answer and this answer. They are similar. Okay, so this is a good sign that both of your mixed differentiation partial derivative are correct. Okay, since del squared f del x del y is equal to del squared f del y del x. Okay, so 40x exponent 4y plus 3. Alright, thus if you were asked to prove that two mixed partial derivative are equal, this is what you need to do. Alright, so if you were asked to find the derivative for both mixed partial, you can just find one, and you say that since the property of mixed conversion say that mixed partial derivative are equal, thus without showing the step of the second mixed partial, you can just declare that the answer is 40x exponent 4y plus 3. Okay, because based on the property of partial derivative, mixed partial derivative, saying that for all function, as long as f is continuous, their mixed partial derivative are equal. Okay. Okay, next for the second example to the second sub equation of this. Let's say you have this function. Now find the first derivative del f del x. Okay, so concentrate on x only. Treat the other variable as a constant. Okay, so this is special because you have x in here, you have x in here, you have x here, you have x here, and you have x here. This is fine, but for these two terms, this one and this one, you need to apply whatever method of differentiation that you have learned previously to differentiate these. Okay, so differentiate these, you need to do products rule. Okay, because you have multiplication of two functions here. For this y, you will treat as constant. Okay, so here, just for this one, you treat u is equal to x, v is equal to exponent x. This is u prime equal to 1. V prime is equal to exponent x. Okay, so for this part only, okay, sorry. This is xy, I forgot the y. So treat y as a constant. Okay, so differentiate that, you will get y only. Okay, so this is exponent xy, y. Okay, so for the first term, you will get x, y, exponent xy plus with exponent xy. Okay, do for the second term here, same, u is equal to x, v is equal to sine xy. Differentiate u, you get 1. Differentiate v, you get cos xy. Differentiate xy, you will get y only. Okay, so for the second term, it will become xy cos xy plus sine xy. Okay, but for this one, it will become 2xy. Okay, so if you want to perform the second time, to directly we apply the second, you need to repeat this again and again. Okay, concentrate on x. So you have x here and here. Okay, you have x in here. You have x in here, and you have here and here. Okay, so this need to be done by product rule. Repeat. Okay, this is fine. This need to perform product rule. This is fine and this is fine. So once again, for this part, you have xy as u, v is exponent xy. Differentiate u, you will get just y. Differentiate v, you will just get y exponent xy. So for the first term here, you will expand this to xy squared exponent xy plus y exponent xy. Okay, so differentiate the second term here, you will get y exponent xy. Okay, that is for the second term. Then plus, you go for this one. This is also need to perform product rule. So treat u as xy. So differentiate this, you will get y. V is cos xy. So v prime is negative sine xy. Differentiate x, you get y. So negative y. So for the third term there, you will get x negative xy squared sine xy plus with y cos xy. Okay, and this will become, the sign will become cos yxy, and 2xy there will become just plus 2y. Right, so what a long differentiation. Okay, so you can simplify whatever can be simplified. I will just leave this for you to simplify, so don't forget the negative sign and so on. Right. Okay, if you want to do it for mix, it will become del squared f del x, because first we perform for x, now we are interested to perform for y. Okay, so by looking at the same function here, now you are interested on y. Okay, so you will just look at this and treat the other as a constant. So this, so you have here in y, you have y here and y here, you have y here, you have y here. Okay, so this need to perform by using product rule. This is also need to product rule, and this will become as usual. Right, so you will repeat whatever you do here and here, 2y. Okay, this one we do for x. Okay, this is also for x. Now you are interested to do for y, so concentrate on y, but still need to perform product rule because you have multiplication of the same variable here. Alright, so do the same. Okay, okay, and repeat the process for the next partial derivative, which is del f del y. After that, proceed with del squared f with the same variable, and then perform for mix. Okay. Right, so I have a empty space here as well for you to write for the second derivative of the same function. Okay, and I also provide the answer at the end of this slide for you to refer. Okay, so I will leave this second example for you to complete it. Alright, so that's all for the first lecture. Hopefully you can perform partial derivative. Okay, thank you. Assalamualaikum.